Alright, so this mean old math teacher going to do some of your work for you. Alright, so obviously, first step here, draw the quadrilateral. I say this sarcastically, but hopefully you can plot points. It is an issue. There's a lot of juniors this year that really struggle with plotting points. And I don't know what to tell you. Like, write 2 down 1. It's kind of interesting. It's almost as though you have a form of graph dyslexia, but there's too many of you to say that that's true. So this is called a quadrilateral because it's got 4 sides, right? What kind of quadrilateral is it? Like, that's a big question. Like, what kind of quadrilateral is this? I do know that this line segment has a slope of -1 because it follows 2 and runs 2. And this line segment follows 3 and runs 3. So they both have the same slope. That means that these two sides are obviously parallel. And that's your hint. I want you to be thinking, as I do this problem, what kind of quadrilateral is it? Because in part 4, I think you've got to find its area. And it's very helpful if you know what it is. Alright, so given a matrix representing the quadrilateral, we have 4 points, so our matrix is going to have to be tall enough to have 4 rows. And all you do is you just copy down the ordered pairs. Just copy them down and move on to another one. It's not rocket science. It's not a hard skill. If you can breathe, you can do this. There you go. That's the matrix. Now, in the next step, we're going to be multiplying it by a transformation matrix. And I don't remember what matrix it is. I can't remember what's special about it. It's just exploring and seeing what happens. So our task here is to take this matrix and multiply it by that other matrix and see what we get. And you do have to show the setup here. Like, that's what you have to do. You got to show the setup. And the setup is simply to multiply these two things together and see what you get. So we're going to multiply those two together. All right? And we're going to use the TI-84 to do it. So if you watch the lecture or whatever, or you were in class, we go to second matrix. We scroll over to edit. And this matrix is a 4x2. She has 4 rows and 2 columns, and we're just going to overtype whatever's in there. Not a hard skill, although I had some kids in first struggling on it. You were. Not sure why. It's kind of interesting. Those kids that struggle, they snooze about 2 or 3 minutes behind. I think they perceive time differently. So I put this guy in matrix A. I'm going to put this next guy in matrix B. So I have to quit out. We're all good at quitting. Second matrix, edit. Scroll down to matrix B. She has a 2x2. And I've already been playing with this calculator, so I've already got stuff in it. Make sure you use the negative key and not the minus key. So -1. I feel like this is a... Yeah, this is a reflection. It's not a rotation matrix. It's a reflection. Yeah, I know what she is. Anyways, we're going to quit out again. Second matrix A, and we're doing times B. So second matrix, choose B. Enter, enter. And here's my result. Okay, so let me go back on the diagram here and graph it, because we're supposed to talk about what it is. Because it says do this, and then it says what? State the transformation, right? So a picture is worth 1,000 words, children. You need to plot your points. So the transformation contains the ordered pair -4, -2. It contains -1, -5. It contains 3, -4. And it contains 1, -2. And then, connect the dots here. And I don't know why, but I see this thing. I look at it, just a butterfly popped into my head. There's probably some sort of psychoanalysis test for that. But that's the line of reflection. And I complain about this every year, and every year I teach is going to be the same. Like, why can't some of you recognize what that is? like legit y equals mx plus b. Slope-intercept form. This thing falls when it runs one, so it's y equals a negative x. Here's the y-intercept. It's at 0, plus 0. We just focus on that. So what is she? She is a reflection over or across. I'm going to use the word across. Y equals negative x. That's what she is. All right, part 4 is kind of rough. Find the original quadrilateral's area. So did you figure out what it was? It is a trapezoid. How do you find the area of a trapezoid is the big question. People write this formula in different ways, but it's equal to, still in subscript mode, 1/2 base 1 plus base 2 times the height. Now, your bases are the lengths of the parallel sides. All right? And the height is a drawn-in segment that forms a right angle with a base. Or actually with both bases, with the bases. And this one was kind of rough on a freehand diagram. Well, actually, it's not that bad. I just wasn't looking at the right thing here. But in order for height and a base to be perpendicular, they have to have opposite reciprocal slopes. Okay? We need to form a 90-degree angle. And I just went over to Desmos to make sure. Oh, maybe I didn't go to Desmos. Bummer. Okay, there it is. Oh, it's gone. No. Well, okay, bummer. I'm not going to spend a few minutes of my life redrawing that. This is my height. This is where it's going to get a little tough for some of y'all, okay? We'll probably just use distance formula to figure these things out. So I've got the ordered pair here 2, -1, and then I've got the ordered pair 5, 1. So I'm going to find the distance between those 2 points. So my height is the distance formula. By the way, distance is the square root of x minus x squared plus y minus y squared. So it's going to be the square root of, let's do 5 minus 2 squared plus 1 minus a -1 squared. All right, 5 minus 2 is 3. 3 squared is 9. 1 plus 1 is 2. 2 squared is 4. And I get root 13. So this one's going to kind of have some ugly answers, but that's my height. It's root 13. Now, again, let me write down the formula again so you know where I'm thinking. I need to know these base lengths. I have the height. I need to know these base lengths. Like how far is this guy, and how far is this guy? So yeah, you can use distance formula. I'm also a big fan of triangles. I'm a geometry person. 3, 3. And you know, you go to one of the oldest theorems we have, a squared plus b squared equals c squared. And that is a right triangle, the way I selected the points. I imagined this. And this is where distance formula comes from. But I'm just going to do 3 squared plus 3 squared equals c squared. That's going to be 9 plus 9. That's 18 equals c squared. So c is the root of 18. And because you guys are juniors, we're going to say 9 roots of 2. Sorry, no, 3 roots of 2. Now, where did I come up with 3 roots of 2? The root of 18 is the root of 9 times the root of 2. So this length is 3 root 2. Now I got to have this length, okay? I also see another little right triangle. It has lengths of 2 and 2. So 2 squared plus 2 squared is c squared. 4 plus 4 is 8. And c is the root of 8, which is the root of 4 times the root of 2, so 2 root 2. Wow, a lot of stuff here. So, let's see what I've got. I've got 3 root 2 and 2 root 2. So my area is going to be 1/2 of 3 root 2 plus 2 root 2 times the height, which is root 13. Okay, think about PEMDAS. I know that's an old lesson, but it's what matters. 3 and 2 makes 5. So this is 5 roots of 2. Still got a half out front. And then we got this root of 13. Okay? Root 2 times root 13 should come as no surprise to you that it's root 26. There's a 5, so a 5, root 26, all over 2. And that is as far as you can take it. It's, by the way, square units, because it's area. That's as far as you can take it. You cannot say this is not 5 root 13. You can't do things like that. That's a radical. It's not a 26 in there. It's actually something a little more than 5. So that's as far as you take that thing. Good stuff. All right, so here we're doing determinants. I'll do 5. So let me go over the rule. The determinant of a matrix that contains the elements A, B, C, and D is A times D minus C times B. That's all it is. So I'm going to do 2x times 4, take away, it's always take away, the product of 2x and a negative 3. 2x times 4 is 8x, a negative times a negative is positive, 2x times 3 is 6x, and we get 14x. Calculator couldn't do number 5. Could not do it. Couldn't do it. Wouldn't do it. And let's see here. I guess I'll do 2 of these. I'll do 7. I'll do 7 and I don't know, maybe 9. But, you know, you really need to be trying to do number 8 because you need to learn how to factor. Quadratics are a cornerstone of this class. I've been trying to kind of get you guys into them. So we're going to do x times x, take away the product of negative 2 and 4, and we know it's going to equal 24 because we already have the outcome. X times x is x squared. Don't be that kid who thinks it's anything else. It ain't 2x, it's x squared. Negative times negative is positive. We're going to subtract 8 from 24. That's what I'm doing. 24 minus 8 is 16. And we counteract a square by square rooting. And don't forget there are 2 answers, so plus or minus the 4. Beautiful. Plus or minus the 4. All right, moving on to number 9. I said I do 2 of them, so I'm going to. We're going to do a 7x times an x, take away the product of 8.5x times a negative 2, and we know the result is 12. So this is going to be 7x squared. 8.5 times 2 is, believe it or not, 17. A negative times a negative is positive. And we talked about this in class. If you have a quadratic with 3 pieces, you're going to set it equal to 0. So 7x squared plus 17x minus 12 is nothing. You're going to factor. It takes a 7x and an x to create a 7x squared. Your factors of negative 12 are going to be 3 and 4, and you've got to be careful about where you put them. I feel like it looks like this, 3 and 4. The reason I'm doing that is because now the outside makes 21x and the inside makes 4x. And if I do subtraction, I can get to 17. So minus plus. That yellow probably not showing up too well. Now we're going to use the ZPP, the zero product property. 7x minus 4 is equal to 0, or x plus 3 is equal to 0. We're going to add 4 to both sides. We're going to divide by 7. X is 4/7. We're going to subtract 3 from both sides. X is negative 3. And there you go, kids. This was not a hard homework assignment. I did one of the big ones for you. 3 of the small ones? So you got 2 problems left on this page, 2 on that page. That's 4. And of course you got the first problem, which had 5 parts. But you know, that was the big one. If you need something, you got to ask for something, right? That's the rule. That's the rule. All right, see you tomorrow.